Okay, so this is the second video. This is, you can complete this worksheet after you've completed the calculating formula mass and molar mass worksheet and watch that video before, because you need to use those pieces in this next part. So I'm just going to read the directions for you, highlight a few things that I think are important for you to consider as you go forward. So be sure to show all work as shown in class. So as this video is going on, we are going to use dimensional analysis. That's key here. When using molar mass, please only keep 2 decimal places. I am going to scratch that out because you're going to, in molar mass, you're going to keep the whole number. So keep whole number. And that's referencing to our periodic table. So remember, when we take the mass of a particular element, let's say chromium, we're not going to keep all of the masses here. We're just going to keep the whole number. So 51.9961 would round to 52. Okay, and so when we use the mass, and even in compounds, we're going to use 52 instead of that 51. Okay, so round all answers to proper number of significant figures. So significant figures, you can typically look at what you start with. So for an example, this problem here, we only need 2 significant figures in our answer. We need 2 significant figures, 3 significant figures in our answers. Box your final answer. Be sure to include units and formula of element or compound. Numerical portions of answers follow each in italics. So these right here, these are the answers on the entire worksheet, so you can easily, quickly check yourself. Keep in mind, the answers may be off just a little bit because these numbers were calculated as if we had 2 decimal places. Okay, so you may have a little bit smaller or bigger number depending on how you rounded when we keep the whole number for our masses. So we're just going to do a couple of these to kind of show you. You've actually done these before in a previous unit. The first several of these problems are of elements only, and at the bottom half of the packet or the worksheet, you will do compounds, and that's kind of the new stuff. So let me just do a quick review of what we are doing here. We're using molar mass, okay? And with that, we want to use the relationship that 1 mole of any substance is equal to 2 separate things. It's equal to either the mass in grams from the periodic table or Avogadro's number of particles. Particles can be atoms or molecules depending on what you are dealing with. Okay, so these first couple are going to be of single elements. We would be using atoms. Okay, so in each of these problems, there's a grouping of them. This first set, we're going to calculate the number of moles. Okay, so we're going to use what's given. I'm going to kind of zoom in here. And we want to calculate how many moles are in 0.039 grams of palladium. So we always start out with the given amount. Okay, palladium is PD on the periodic table. We're going to put what's given over 1. And then we're going to line our units up. And so because of our conversion factor that we talked about earlier, 1 mole is equal to the mass in grams, we can go straight from grams to moles. Okay, so line your units up. Remember, whatever unit's on top, we put on bottom so that those units cancel. 1 mole of palladium. Okay, we get our periodic table, we go back over, we find palladium. PD is right here, 46. We're going to use the whole number of that. 106.42 rounds just to 106. So that is the mass that we use here. And as you can see, our units, grams and grams, will cancel, leaving us with the desired unit that we want. Our calculator now, we take our calculator and we divide 0.039 divided by 106. We only need 2 sig figs, and what we get is a really long number in the calculator. Okay, and I'm going to show you how to abbreviate this. This would be way too many significant figures. We only need to keep these 2 right here. So 3.7, yes, we would round that, times 10 to the 1, 2, 3, 4, and that 4 is a negative. Our unit here would be moles. Okay, Now, this is just an example of how we use the conversion factor here and there. Keep in mind some of these will have prefix units, like this one is going from kilograms. So for something like this, you would have to go from kilograms to grams and then moles. Okay, other sections, you can see they all ask for a little bit different things. This next section, we want to find the mass in grams given a set of moles. You're going to be using the conversion factor just the same, it's just going to look a little different. So let's do one of the problems from here. Let's do 2B so that you can kind of see one with the prefix units as well. Okay, so we're trying to find mass in grams from m moles, so that's millimoles. We're going to start out with the given. Put over 1, and this is of aluminum. Okay, before we can go to grams, we need to get our unit into moles. So we're going to go millimoles to moles, and then moles to grams. Okay, so this middle section here, okay, we learned this back in chapter 1. We need to use our prefixes. So we typically put a 1 with the bigger unit of the two, and so in this case, moles is our bigger unit. And our smaller unit, we would jump on our, King Henry die chart. It's 3 jumps away, so it gets a positive version. Then over here, this is the molar mass of aluminum. So 1 mole of aluminum is how many grams? We go over to our periodic table, find aluminum, round to the nearest whole number. We would do 27. That number goes with grams. And then if you look at our work, okay, let's double check our units, make sure those cancel out. Millimoles, millimoles, moles, moles. Now we are just left to calculate. So remember, we multiply all the numbers on the top. So in this case, we would do 550 times 27 divided by either 1E3, or if you know the value of that number, that is 1,000. And we need 2 sig figs, so calculator we get 14.85. That has 4 sig figs. We need to round that to 2, so 15. In this case, unit would be grams of aluminum. Okay, so